Hey, everybody, we're talking about pyramids today, and I'm wearing my Baylor Bears hat in honor of the Baylor Bears NCAA championship victory. And I'm no bandwagon fan here. My daughter's been going to Baylor for 7 years, I'll have you know. So, way to go, Bears. Anyway, let's talk about pyramids. Pyramids come in different kinds, okay? There's not just one kind of pyramid. The pyramids that have been built around the world generally come as what we call square pyramids. They have a square base, a square bottom that they stand on, and then triangular surfaces around the perimeter, so to speak. But pyramids do not have to have a square base. They could have any shape base you want. They could be a hexagon shape like that, and then all of the sides. Let's save this here. All of the sides reaching up to a point at the top. So you could have a pyramid like that. You could have a triangular pyramid, right? Triangular base, and then all of the sides are triangles, also going up to a point at the top. Okay. What makes all pyramids is that all of the side surfaces, the surfaces around the perimeter, are always triangles as opposed to rectangles for prisms. But then the base can be any shape that we want it to be, any polygon shape, really, that we want it to be. Mostly, I think maybe exclusively, we're going to be dealing with square pyramids in this unit where the base is a square. And so we're going to be finding the surface area and the volume of this period today. And again, there is a formula for surface area which you can go up and look and use, and that's okay. But you got to know when to use it and how to use it. Okay? And you still need to understand, the general idea of what surface area means and how to go finding it when you're dealing with an object that is not as simple and straightforward as something that you can look up a formula for. Okay? So I'm warning you. Don't just think you know enough about surface area or surface area of pyramids that you can just rely on a formula. Okay? If you don't do the homework problems and work through them, you're setting yourself up for trouble. Right? So what are all the distinct areas of a pyramid? Well, there is this bottom surface, okay, which is now it doesn't say on the notes here that this is a square pyramid, and it also doesn't say something else, which is technically necessary here. This is intended to be a regular square pyramid. Again, it doesn't say that. It really should. That's why I'm writing it in. Okay? A regular square pyramid. The word square means that the base is a square. The word regular, you recall that word regular means sameness. And what that means is that all of the triangular faces around the pyramid are all the same size. Okay. It may not look at it from the perspective of this picture that this triangle in the front, let's say, that triangle in the front might appear to you to be a lot wider, bigger than this triangle on the side. But think about it. If the base of this pyramid is a square, okay, then this side of the square from A to B, 16, that must be the same length as this side of the base. That must also be 16. And so that triangular surface on the right side of that pyramid is truly the same size as that triangular surface in the front there. That point D must be directly over the very center point of that square base. That's how you get a regular square pyramid. And I believe the pyramids that have been built around the world are, in fact, regular square pyramids, or at least they were intended to be like that. Okay. So going back to the base surface now, let me just get rid of some of this clutter. The base is a square. Okay. Okay, and so if one side of the square is 16, then all sides of the square are 16. Okay, so 16 times 16, that would be, well, I'm not going to write the calculation in that space. I'm just going to write the result. The area is going to be 256. There's only one surface of the pyramid that is that size and shape, right? Unlike in the rectangular prism that we did in our notes in the previous lesson, where there was a back that matched the front and a right that matched the left and a top that matched the bottom. I mean, every surface in a rectangular prism has a matching surface like on the opposite side. Not so in a pyramid. The square has no matching surface. It's by itself. However, when it comes to the triangular surfaces around the pyramid, there are 4 of them, and they're all 4 the same if it's a regular square pyramid. And when I give you a pyramid, it's not going to be anything other than regular ever. And I think they're all probably going to have square bases too. But even if I gave you a triangular pyramid, I would give you a regular triangular pyramid where all of the triangular surfaces were the same. Now, what are the base and height of one of these triangular surfaces? Well, we've been given a measure of 17 in the picture there. That's that distance from point D. Oh my goodness. That's that distance from point D down to the base of that triangle forming a right angle. Okay, so that's 17. That's that height right there going down at a right angle to the base. The base is 16. 1/2 times the base times the height is 8 times 17 is 136 for the area of that one triangular surface. There's 4 of them, so that is 544 square units. When you add the 256 plus the 544, we get a nice round 800 square units. Remember, this is area. Surface area is part of 3-dimensional objects, but it's still flat area measurements. And so it's still square units, not cubic units. Okay. Now, again, I know there's a formula you can look up for regular square pyramids, and you can plug some of these dimensions in and get this answer even more quickly, but understand the general idea of surface area, which is to find all of the individual surface areas and total them up. Okay. All right. You know, it did not show in the diagram either, and it should have. There really should have been a right angle mark where that segment DE was meeting segment BE. That right angle mark really should have been in there. We don't want to assume that that segment is forming a right angle. We don't want to assume that that is, the height of that triangle. That really should be given to us. So that's an oversight in the notes. The right angle should be there. Now, before we scroll down the page and talk about the volume of the pyramid, I want to introduce you to a couple of new terms. Okay, those terms are height. That doesn't sound new. And lateral height. It's a 2-word term. Lateral height. Okay. There are 2 different kinds of heights in this pyramid. And you should know which one is which and what the differences are. When we talk about the height of a pyramid, the height, like as if it were the one and only height, we're talking about the height from the top point of the pyramid down to the base of the pyramid at a right angle like that, as if you were measuring the altitude of this pyramid. Like, what is the elevation of this point on the pyramid? Is it 1,000 feet high? Is it 2,000 feet high? How would you measure that altitude or elevation? You wouldn't measure it by taking, a tape measure and measuring up the side of the pyramid like that, right? So this distance is called the height of the pyramid. Now, this segment over here, DE, that turned out to be the height of this triangle. It is the height of one of the triangular surfaces. And so we call that length there the lateral height. The lateral height, because it is a kind of a height. Okay, but what does this word lateral mean? Most of you have probably heard that word before. I can think of two contexts very commonly, and where you might, maybe three, where you might hear that word lateral. One is in the game of football. Okay, if you throw a lateral pass in football, technically the rules of football declare a pass a lateral as long as you don't throw it forward. You can throw it backwards or you can throw it to the side, but as long as you don't throw it forward, it's called a lateral. Okay. Some of you probably aren't familiar with that terminology in football. But if you've ever played a sport, certainly at the high school level, okay, if you play tennis, basketball, football, hockey, they might do this as well. You probably engage in some point in what your coaches would call lateral running drills. Okay. Running drills where you're not running forward, but where you're running side to side, where you're kind of shifting side to side. Okay. It's the sideward movement of those running drills that makes us call them lateral running drills. The word lateral is an ancient word meaning to the side. I don't know if it's Greek or if it's Latin. Okay. But that's what the word literally means, side or sideways, lateral. Okay. And you have to do that kind of movement when you're playing sports, right? Which is why coaches make you run those sorts of drills. Third context I can think of that word lateral, some of your muscles are referred to as lateral muscles, or that root lat is in some of your muscle names, like latissimus, I've forgotten my muscle names. I learned some of them many, many years ago. I've forgotten what they are. I'm sure there are some muscle names with that root in it, though. Okay. So height is like the altitude of the pyramid. How tall is it? Okay. Whereas lateral height is the height sliding down one of the side surfaces of the pyramid. And it is the lateral height that we need to calculate the surface area. Okay. You must be clear on this. Again, you got your formulas that you can look up and just plug numbers in, but you better be plugging in the right numbers from the right places. Okay? This is the measurement that you need to find the area of that triangle and therefore the surface area of this pyramid. Now, let's go down and talk about finding the volume of this pyramid. Here is a formula for the volume of pyramids. I need to talk about the capital B and the lowercase h. Okay, the capital B stands for not the same thing as a lowercase b, and that's why we make it a capital B. A lowercase b, let's say we're talking about the area of a rectangle or a parallelogram or a triangle. Let's say triangle. We got 1/2 times lowercase b times h, and that lowercase b stands for the word base. But when we're talking about triangles, the base is a length. It's a length measure. Okay? It's an edge of the triangle. This capital B stands for the two-word phrase base area. Okay? And that's why we make it a capital B, so nobody confuses it with a lowercase b thinking base edge. Okay? You've got to find the base area, and in this case, the base is a square. But as I said earlier, the base of a pyramid could be all different kinds of shapes. Okay? And imagine, what if the base were a circle? Okay. Well, we have a different formula for the area of a circle. But we would still need to find that base area. The volume of this thing is exactly the same formula as the volume of that thing. It's 1/3 times capital B times lowercase h. But this capital B is going to be calculated differently for this object than it is for this object because it's a different base shape. Okay, so you have to know that, all right? By the way, we don't call this thing a pyramid, technically. I mean, we could call it a circular pyramid because it's got a circular base instead of a square pyramid or a triangular pyramid. But you probably know what we call this sort of three-dimensional shape, right? I'll save it for the next lesson, just in case you don't. We'll leave that as a surprise, but I think all of you know. All right, so capital B, base area. And then that lowercase h stands for, you got to know this, the height. The height. The height that I was talking about earlier up here. The height, as if it were the one and only height. The height from the top of the pyramid down to the center of the base, as if we were measuring the altitude of this pyramid. It's not that 17. That is not the height of the pyramid. It's not the measure we need to calculate the pyramid's volume. We need this distance right here from D to F, and it hasn't been given to us. Okay? And yet, there's enough information in this picture for us to find that height and then calculate the volume using that height. So how are we going to find that height? Well, I might let you think about it and suggest some things and come up with some ideas if we were in class, but we're not, so I'm just going to have to tell you. If you connect that point F to point E, we create a really nice right triangle between points D, F, and E. Right? Because that segment DF from the top of the pyramid straight down to the center of the base, that forms a right angle with segment FE, and then connect E back to D, and we got a really nice right triangle in there. And we know the length of the hypotenuse. It's 17. Now, if we're going to find the height, it sure would help to know the length of that side of the triangle. I mean, without it, we're kind of stuck. Any ideas how long that segment might be? Again, if we were in class, I'd ask for responses. Somebody would get this, I'm sure. Somebody would be able to figure that. It's not hard, right? I mean, from A to B is 16. So how long is it going to be from F to E? F is right in the center of that square. From the center out to one side, how long is that going to be? It's going to be 8, isn't it? It's going to be halfway across that square. Okay? Now, no Google searching is going to help you figure this out. Okay? You got to see the relationships here. You got to understand that you need this h, not the 17, to get the volume. And now you need to understand that you're going to have to put the Pythagorean theorem to work. H squared plus 8 squared is equal to 17 squared. Do your little work on that and solve for h. H turns out to be 15. Now we have all the numbers that we need to calculate the volume of this pyramid. Volume is going to be 1/3 times the base area. The base area is a square. And the square's area is just going to be 16 times 16. Right? That's your base area. And then your height, we found out, is 15. Okay? So I got to do this arithmetic in my head because I didn't work it out ahead of time. This is 256. 1/3 times 15 is 5. 256 times 5 is 1,280 units cubed. It's volume, cubic units. Okay? Now, that's it for the notes. But I want to give you a sneak peek at the homework. The homework is not short, and there are a number of questions, a number of them that are really going to make you think. Give yourself time to work through this homework and put in the work. If you don't want to be panicking on the next quiz or wasting all of your time trying to Google how to do problems because you haven't put in the work and not finding any help on Google because you won't, then do the homework assignment tonight. But let me open it up for you. Should be able to find it. 13.2. Not there. Sorry for the delay, but I'll find it here. 13.2. Here it is. All right, no thanks. All right, problems 1 and 2 concern this period here. I'm asking you to find the total surface area and the volume. Now, notice this 13 over here, right there, that's the lateral height of the pyramid. Stop. That's the lateral height of the pyramid. And you need that lateral height to find the surface area, okay? But the height that you use for the volume is not that 13. You need this height, and you're going to have to find it to get the volume. And you're going to have to do just what I modeled for you in the notes. Connect that height to this lateral height in a right triangle and use a Pythagorean theorem to find it, okay? Now let me give you a warning about the next problem. In the next problem, I want you to find the volume and the surface area, okay? And this time, notice I've given you the height, which is what you need to find the volume. But to find the surface area, you need to find this segment, the one that comes down at a right angle to the bottom edge of that triangle. How are you going to find that? I didn't give it to you. Same right triangle trick. Okay? Connect that lateral height that you're looking for to the height that I've given you with the side running halfway across the square from the center to the edge, and put your Pythagorean theorem to work. Okay? You see how looking this up on Google, not going to help you. Okay? Once you have the measures you need to use any formulas that you want to look up, then fine. But you got to make sure you got the right measures. Okay? Here's a problem that's going to make you think a little bit. Not a lot, okay? But it's going to make you think. I don't know that you're going to be able to Google any help on this one, okay? Oh, here's a great surface area and volume problem, okay? Surface area is really going to make you work on this one. Volume, not as much work, okay? But you're going to have to think. Oh, I love this problem, this set of problems here, 8, 9, and 10. These are going to make you think a little bit. The calculations for these problems are not long or difficult, okay? But you are just going to have to do a little bit of thinking to use the right numbers, okay? And number 11 is going to make you think a little bit. Again, calculations, not that many, not very hard, but you're going to have to think. So give yourself time. Start early on this homework assignment, maybe. Earlier than you usually do. Maybe expect it's going to take a little bit more time than it usually does. All right? That's it. See you next time.